All right, let's get started with the day. I will quickly share my screen. And today we're going to have another class or session in which we will understand how the components of SD-WAN fabric and architecture looks like. So we're going to get familiar with, as I said, SD-WAN components. I hope I'm audible and my screen is visible.
Yes, you're audible and screen is
Okay.
also visible.
Now, the section actually introduces you with the working infrastructure or architecture of how each and every component in this SD-WAN fabric works. We have data plane, which we will discuss about. Then we have management plane, we have control plane, and we have orchestration plane. These are the four planes, combining all of which we get SD-WAN fabric as an outcome. And
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
it is a bit different than how traditional networks actually work. So in traditional networks, the management plane, the data plane, and control plane are all on same device. Mostly something that we discussed yesterday. And together, they facilitate communication within the network. So as I said, on a traditional device, we generally have components like we have line cards, then we have CPU, and then we have CLI or GUI, by using which you basically form up a device so that it can actually forward the traffic. Line card definitely playing role in order to forward the traffic. CPU playing the role in order to calculate the best path, and CLI or GUI in order to be able to configure how the CPU should perform. So this is our traditional management plane. This is your traditional control plane. And that's your traditional data plane. So each router in a network has these three components. Now, when you look at a traditional network, let's say you have number of routers, and each of which needs to be programmed independently to achieve the desired operational state of your network. So, and as the network gets larger and larger and larger, the amount of human intervention that is required to configure the topology dramatically increases. So, for example, if you have a scenario like this, I think I explained to you yesterday as well that if you have R1 which has around 3 neighbors, and then all of these three are connected to another network, and this has a loopback like 50.x/24. When the network is going to be advertised, it is going to be learned by all these other devices. And then these devices would propagate that particular route further. But before that, R2, R3, and R4 also did configure the or did calculate the best path selection. And after they came up to the answer, then they started advertising those particular routes out. That's how it works. If I add some more devices, maybe R6 over here and R7, and then create a connectivity with this in this way, then you can see how big the network would be. So the 50.0 network will be advertised out, and then R2, R3, and R4 will have to advertise it over here, over here, over here. Then this over here, over here, over here. Make sense? So as the network keeps on growing and growing, the amount of calculation increases, which actually adds more overhead onto the calculations that a CPU needs to do of a specific device. So increasing network requires your routers to have necessary available CPU and memory requirement to process these updates, which in turn creates lots of overhead, as I said. Now, SD-WAN works in a different way, however. In SD-WAN, the architecture looks in some of the way that the first layer is actually your controllers. So you basically have SD-WAN controllers in one of the scenario, which will basically have vManager, then you will have vSmart, and then you'll have vBond. This all is kind of into one picture. And after this, you basically have multiple types of transport. So you can have internet transport, or you can have MPLS transport, or you can have something like 3G or LTE as your transport. So transports can be anything, and it doesn't require you to only use a certain transport, unlike legacy networks. That in order to be able to connect to your site, you must go for MPLS so that you can ensure the site-to-site connectivity or things like that. Now, if I say that these are our ISPs, and your controllers are connected to the ISPs in any of the ways. You say connectivity is over here, here, here. Okay, to all of them. Then you can set up your branches. So if you have your WAN Edge router that is situated in London, similarly you have your WAN Edge device that is situated into USA. You have another branch that is situated into Dubai, and you have another branch that is situated into Delhi. And let's say the USA is headquarter. So what do is you actually connect most of these branches with these, and then these would probably have connectivity to these. So how you work with it is you probably are looking forward that employees are sitting right away over here, right? These are your employees, and you want these employees to communicate with each other, correct? And from here to here, from here to here, from here to here, then from here to here, from here to here, here. There should be communication between all of them throughout. But that communication actually needs to be done via any of the transport. You cannot just directly like lay a cable between them and then make a communication possible. It cannot work like that. You need to go through your ISP. So what happens is it is only the data plane that actually exists onto the endpoints. There is no control plane or management plane that actually exists onto these endpoints. So the control plane is managed by this. The vSmart manages, oh, I'm sorry, I made a mistake. The management plane is managed by this. The vSmart manages the control plane, and vBond manages the orchestrator plane. Everyone has their own responsibilities, and the architecture kind of differs from traditional networking. It allows you to support large scale networks while reducing the operational and computational overhead, because the control plane knows about all the routes and nodes of the network. You have to calculate the routing table only once. For example, if you're going to have a prefix like 10.x.x.x. So if you have a network like this, and then here you have 20.x.x.x, and then 30.x.x.x, and 40.x.x.x, all of these networks will actually won't be advertised out over here directly, or to this or to this. That's not the advertisement that it's going to go through. Your vManage will only advertise the 10.0 network to the control plane, vSmart. Then vSmart will advertises over here, and over here. And you can push a policy and you can say, for example, you don't want 10.x network to be advertised out to Delhi. So you can tell your vSmart that whenever a route from site number one comes up, do not advertise it out to Delhi office. No, don't advertise that. By default, it is going to advertise that, but you can definitely push a policy to not let your controller advertise those routes received from specific site to other specific sites. Once these advertisements are done, then your traffic will actually flow between the direct tunnels that they are going to maintain. So it's like the communication doesn't go via this to vSmart and to this. It just goes out to the transport and then returns back because the tunnels are maintained in this way, right? That's how the IPsec tunnels are going to be maintained, either on any of the transport. It doesn't require only MPLS to create a tunnel, but all of your tunnels can actually be created with any of the transport, meeting the same level of security. Security is also not a concern. So people do have a misconception that SD-WAN is going to replace MPLS. Well, the clear answer is no. SD-WAN is not going to replace MPLS. You are still going to require MPLS because of the quality of bandwidth and the quality of service that it provides you. It's you cannot really rely on commodity internet or some other type of ISPs or transports to achieve the same level of performance. So you can, however, depend on to the commodity internet or 3G or cellular networks when the data is not latency sensitive. But if it's a latency sensitive data, then you probably would require a trustable transport to be there into your fabric so that you can use it. Make sense? Do you understand the overall idea about the architecture, that how it is divided? Now, how do they communicate and how does the data communication work? So which are the tunnels that are formed? All of that we're going to talk about just coming up. But this is I'm talking about the architecture. Do you understand the separation of them? Any questions?
Yeah, what is orchestrator plane? Is there something?
It's an authenticator of the fabric. If your vanish is going to become part of the fabric, then the first point of touch is the orchestrator. So orchestrator will define whether the vanish is legit or not.
Okay, got it.
So
So how we can
so
add any device to the SD-WAN? So suppose I got one
we are gonna
device.
do that.
Okay, okay, no problem.
Now, one
Abhijit,
time,
here.
yes.
So what are the like template we create in vManage that need to be pushed in vSmart, right? Or else
You
we
don't need
can.
to put visually into vSmart. It is done on the back end.
Okay.
You
Do you
just
have
need to
any,
push device,
how
but
it will work in
vManage.
backend?
We will talk about that. It's too early to
Okay.
talk about them.
Okay.
Okay, so every site
Now,
will have tunnel to the vSmart, right?
with every controller. Okay,
Okay.
so we're just moving on to that. So we will discuss about each and every plane individually. First, we will talk about data plane, then I will talk about management, then control, and then orchestrator. That's what the motive of today's class is. So let's start with traditional plane, data plane, and understand how data plane actually works. Now, traditionally, the data plane is actually composed of physical interfaces, okay? Which means your vAnage. The data plane actually resides onto vAnage. And there are two types of devices that can actually be your vAnages. When we say vAnages, one is it can be your Cisco iOS XE devices that can be your vAnage. Otherwise, it can be your Viptela OS devices that can be managed. So if that's a Cisco iOS XE series device, we call it a CH. And if it's a Viptela device, we call it as a vEdge. But both of them can be referred as WAN edges. You cannot have any other device apart from these two platforms as part of your SD-WAN fabric. If you want to connect a WAN edge within the SD-WAN, then or Cisco SD-WAN, then you must have one of these two devices or one of the devices which are based on one of these two platforms. Then and then only you will be able to connect them. Now, which are the device models that are supported on them? The devices that can actually become part of your fabric are categorized into three categories probably. The first category is for Cisco's devices. So you can say Cisco iOS XE physical devices. And then you have Viptela OS physical devices. And then you have Cisco and Viptela virtual devices. So in the iOS XE, you can have Cisco ISR, I think 1000 series. Then you can have Cisco ISR 4000 series. And you can have Cisco ASR 1000 series devices, which can actually be part of your fabric. Talking about Viptela devices, there are some additions as well. I think ISR 8000s can also become part of your fabric nowadays. They have launched the support for that. Then on the Viptela OS, you can have Viptela 100 series devices, Viptela 1000 series devices, and Viptela 2000 series devices, and 5000 series devices. These are the physical devices from Viptela that can actually become part of your fabric. And then talking about the virtual appliances, you can have CSR 1000V, then ISRV. Both of them are Cisco. And you can have vEdge Cloud, which is another virtual appliance made by Viptela that can be part of your fabric. These are the devices which can actually act as vManage. You cannot have Juniper or Palo Alto or any other device that can become part of your fabric. These devices can be placed on-prem as well as on cloud. You don't really require them to be placed on site only. You can also have host them into solutions like Azure, AWS, or Google Cloud Platform. You can also host them into CSP as well, Cisco Cloud Service Platform. So Cisco also has its own cloud service platform like Azure and AWS. You can host them over there as well. Now, when you look at these WAN edges, the WAN edges needs to be upgraded to iOS XE SD-WAN edition. So if you have like Cisco iOS XE devices from the legacy networks, you cannot just say that the same legacy devices with the same OS can actually become part of the fabric. Those devices definitely have the ability to get connected to the SD-WAN fabric. You don't need to scrap them, but you need to perform an upgrade or update the iOS to SD-WAN edition, and then you would be able to make them part of the fabric. That's something that you need to take into consideration. Also, while considering which vanish to go with, whether you should go with Viptela or with Cisco, then for this you will need to understand your throughput requirements or your data plane tunnel requirements. For example, how many other branches the router will be communicating with, and what type of interfaces are needed. Like Cisco vEdge, which means Viptela devices, they support Ethernet, LTE, and wireless interfaces. But the iOS XE, which means C edges, they support platforms such as like voice and serial interfaces, right? And both platforms are interoperable on the SD-WAN fabric. You can have some of the sites having Viptela, some of them having C edge, all of them having C edge, or all of them having Viptela. That's completely your choice. No need to go with any specific mode of the device. You can have any combination of that. Make sense? About their onboarding. how does they or how do they work with each other? So we were going to talk about how the data plane actually establishes a communication between both of them. So each router actually, whenever you place them into the data plane, let's say this is your site in London and this is your site in Dubai. So you have a vManage and you have another vManage, and then there is a transport, maybe iNet. So you connect your vManage to iNet and you connect your vManage to another connection to the iNet. What happens is your vManage is going to form up a data plane connection. That data plane connection will mostly be an IPsec tunnel. Okay, which means that if you have any LAN segment 10.x.x.x and 20.x.x.x and they want to communicate with each other, the communication will only happen via this IPsec tunnel. Okay, which means that the in the other way you can say that in the iNet fabric, in the ISP cloud, there are hundreds of routers, right? That will be there to connect London with Dubai, right? This, and this is what ISP cloud is. And then you would have a connection to the other end. So whenever you look at the black cable and understand that there are so many devices, we basically treat it as the underlay. Okay, or you can say SD-WAN underlay as well. And when you look at the IPsec tunnels that are going to be maintained, the IPsec tunnel will be called as overlay of the SD-WAN fabric. So when the communication between the site to site is actually done 10.x.x.x to 20.x.x.x, the communication from site to site will always be done via the overlay. It will never be done via underlay. But for the overlay to come up, your underlay actually must be pretty much reachable. If you have an issue in the underlay, then overlay will never work. You get that? So which comes to a conclusion that each router will form a data plane connection to the other routers within the SD-WAN overlay for the purpose of like transporting user data. And the data plane connections which are talking about, which are basically nothing but IPsec tunnels, they are only established between data plane devices. Okay, these tunnels are secured via IPsec, which comes to a conclusion that if you have your vManage, come on, if you have your vManage, vSmart, and vBond, you cannot have any IPsec tunnel with those devices because IPsec tunnels are only meant to be used for data plane connectivity and not for any other sort of connectivity. And there is another, you can say, thing that the tunnels are actually created automatically. As I told you, that Cisco Tech created a report that around 70% of their customers create tag tickets for connectivity not being up, for their site being down and not accessible. And then 90% of the issues from those customers are because of the misconfigs. So Cisco kind of took away the load from the user to actually configure phase one, phase two parameters and all of those things. And as soon as you provide underlay reachability, your IPsec tunnel will automatically be formed. There is no phase one config, phase two config that you need to do, or IK version one config or so that you need to do at all. The config is by default there with pretty top-notch encryption and encapsulation standards and all, and your IPsec tunnel will automatically come up. You don't need to manually onboard your IPsec tunnel at all. If the IP reachability is there, then the tunnel will come up. And apart from that, you can say there is something that is called as a protocol is used, which is called as BFD. BFD stands for bidirectional forwarding detection. Okay, so when we look at BFD, you can say BFD hello packets are sent from here to here. And if the hello packets are being acknowledged back, which means that the network is healthy and the IPsec tunnel will come up. So BFD hellos are sent in order to measure the link liveliness, okay, between all the WAN edges. And it basically calculates parameters like jitter or loss or delay factors, and then it is able to measure how the transport is actually performing. Because you have features like application aware routing and all, for that your vManage performance needs to be calculated so that the solution can figure out if the transport is performing within the expectations or not. And one more thing is, these hello packets do not need to be processed by the router, by the vManage. Okay, the hello packets can just be acknowledged back without processing it, because your vManage might be too busy handling lots of other things. So if it creates delay in processing the BFD hello, that can kind of indirectly measure a wrong parameter of how the vManage is performing. So that's why without BFD hellos being performed or being processed, your vManage can just acknowledge the hellos to just specify whether the link is up or not. That because that's the only motive of BFD is sending hello. And this greatly reduces the CPU impact as well, because the neighbor doesn't need to process these packets. So by comparison, if the neighbor was involved in the processing of BFD packets, then the remote neighbor's CPU was busy with some other processing, then there could be potential delay in responding to those packets. But by eliminating this, you could basically be there could be potential delay in responding to those, and you can reduce the outage detection time and improve the user experience, because that outage detection time or outage time would be false if it's so. So that's kind of an advantage of having BFDs being used in order to measure the link liveliness. Now, another thing that you need to understand is how the vManage actually works. So, how does it get the information? Because if I would like to explain you, the IPsec packets or IPsec tunnel is only maintained so that the actual user traffic can be sent from this end to the other end. Which means if you have a backend link, or if you have a network 10.x.x.x and the network goes down, then the vManage needs to create an update and send it to the other devices. But these routing updates are not sent into the IPsec tunnel. The routing updates will be sent to some other tunnel to the controller, and it works like a BGP route reflector. Okay, your vManage is not responsible towards sending the routing updates to the other vManages. In this case, if there are like 100 of vManages that are connected, then your router will have to send the update to 100 others, and those 100 others will have to process that particular things. So you can see how many exchanges and how much of utilization would be there. Instead of that, the vManage is actually supposed to send that particular routing update to vSmart. vSmart updates the routing table and it just sends an update, nothing else. The vManage doesn't need to process that update and see what's wrong. It will be processed by the controller, and controller can take the decision and send any update, and then the new route or any route that needs to be withdrawn from the vManage will be done by the vManage only. But yeah, no need to be processed by your vManage. So that's another thing, which means the IPsec tunnels are only used for sending the user traffic, not any updates or nothing. That's one more thing that you can consider, and this is how the data plane actually works. Questions?
So first VPN tunnel will happen with the vSmart, right? After that vSmart is
There is
owner
no,
for the uh,
I mean,
okay.
there is no IPsec tunnel with vSmart or so. Those are different tunnels, but that will be a VPN tunnel, so that we can say that's correct.
Okay.
Here, So when IPsec tunnel is established, only the data will be passed from one location to another location, right?
That's correct, yeah.
So
The
no
routing
other.
by some other tunnels, two other controllers.
So if we establish the communication like two devices, two location devices need to like communicate each other. So for liveness. So in that case,
Then,
we can use overlay, right? Overlay or
yeah.
underlay, right?
Well, underlay is used in order to measure if the tunnel can be established or not. If your
Oh,
underlay is good, then the overlay will be formed, and then
okay.
the IPsec tunnel will be up, and then your traffic can go from the tunnel.
So in underlay, what are the components will come and like a vEdge router and internet routers and the other
Yeah,
and the vEdge router.
other
That's
VH router.
okay.
That's correct. Yeah, it's just the
So
IP
over.
reachability one side to other side, nothing else.
Comes to
Now
overlay,
ISP,
it's IPsec tunnel.
that's correct. But ISP in the underlay can use some other devices as well. It can have a load balancer, it can have multiplexers and lots of other devices that comes into picture when we talk about ISP fabric, right? So those
Okay.
those all come under the underlay.
This is about a
Overlay,
data plane. In data plane,
that's
the IPsec tunnel is overlay, and other things
yeah.
here that underlay, right? Okay. Good.
Mhm.
You said
Now,
the hello packets are sent over the underlay
Mhm.
and will not be processed by the other end router.
That's
Um,
correct. Yeah.
I'm kind of confused that they just reply, but do they use the CPU to do that to reply? And
No.
if they don't, the source router of the hello packets will have also intensive CPU usage to to
Mhm.
to calculate that to process that.
Well, as I said, the package doesn't get processed at all. They just need to send the packet back. That's exactly the process that is done. Which means the response of that particular packets are done by the data plane, not by the control plane. The processing comes into picture when your control plane needs to do some calculation. Correct?
Oh, the controller do the calculation.
No, no. I'm saying so. See, for a normal environment, you can say that um, my router learned some OSPF route, correct? Just giving you a scenario. And that particular route will get installed into the routing table, correct?
Correct.
Before this route gets installed into the routing table, does calculation of the best path needs to be performed by my CPU? Am I correct?
Mm-hmm.
So after the processing of this, then the best route will be figured out and that route is going to be inserted into the routing table. Make sense?
Yes.
Now, after this routing table is installed, the same route is going to be installed into the forwarding table as well, fib.
Mm-hmm.
So when a traffic comes up for that particular route, does that particular router needs to process the route again to calculate where do I need to go, or that calculation is already done by the CPU? Do you understand what I'm trying to say? I'm saying
Done by.
that when I'm saying that when the traffic actually comes up to a router, as I explained you yesterday, if you remember, I have a figure that I have a figure as well for this. This is something that I explained, right? So you get the route installed into the FIP, correct?
Mm-hmm.
When the traffic is going to come, the traffic will be mapped in that FIP table and will be checked if you have any destination route. If the destination route is can be reached out via this interface, the traffic will be forwarded out. So
Right.
there is no calculation that's happening over here. There is no CPU utilization that is being consumed over here. Make sense?
Sure.
This is data plane. But if the route is actually being received, there is a routing update that's coming up. then that routing update needs to be given to RIB. Makes sense? By calculating that's where CPU comes into picture.
Right.
So when I talk about BFD hellos, if the BFD hello packets are being come up or being received, then they can just be replied back. And there is a special hardware for handling all the data plane activities, which is ASIC. So CPU doesn't comes into play for this.
Right, but this is in the destination. So you are going to measure jitter, packet loss, delay, and who do that
That's correct.
calculation?
It is
Who
done
does?
by the manage only. I mean by the BFD. So when you're actually sending the traffic based on the TTL, based on the delay, based on the time taken for a round trip, it does calculation. The calculations are basically done by the protocol itself. BFD is a protocol, right? Bidirectional forwarding detection protocol.
Yes, yes,
That
yes.
protocol calculates these values, and based on that, it figures out how the link is performing. If the packets are being acknowledged back, it just comes to a conclusion that an overlay can be formed within those networks, within that link.
Okay.
Are we good now?
Yeah.
Cool.
Thank you.
Now, when you look at the other way, so this is how data plane actually works. When you look at the other aspect, or the next plane that we got to talk about, it is called as management plane. Now, as mentioned, management plane is actually considered or handled by one of the component into the SD-WAN, which is called as vManage. And vManage plays the role of network management system, the NMS, that provides a single pane of glass to manage the entire SD-WAN solution. And vManage can actually be utilized for onboarding, provisioning, policy creation, troubleshooting, software management, monitoring, and whatnot. Okay, analytics, and all. So, and even the certificate installation and all of those things. So, vManage is your centralized GUI that actually gives you the ability to play with the fabric entirely. And though the vManage, you can say, is kind of the most strongest resource that is used into the SD-WAN fabric. So it comes in the form of a virtual machine. Okay, and it needs to be installed into a server. But in the production environment, it is recommended to have a resource of at least 24 GB for vManage to be installed, and around 8 CPUs on the server, and around 200 GB of RAM. This is a recommended resource that you need to have on your server in order to install vManage. Okay, so the minimum resource, however, you can use in order to just boot up and work with around 2 or 3 or 4 sites. You can boot up the vManage with at least 8 GB of RAM. You cannot boot up with less than that, and 2 CPUs, and around 30 GB of RAM, 30 GB of hard drive. That's the resource that you're going to require at least in order to just boot up the vManage. But to make it work in the production, it is recommended to at least have 24 gigs of RAM, 8 CPU, and 200 GB of storage. Then, if the size increases of your production, you can increase the size of the resources as well, and then keep on increasing as the requirement goes. But one vManage can handle up to 2000 WAN edges. Okay, one vManage can handle up to 2000 WAN edges, and depending on the need, it is highly scalable. So depending on the needs of the environment, when you want to cluster, when you want to create a cluster of vManage, you can have at least 3 vManages to create a cluster, and the value can go like 5, 7, 9, 11, or things like that. but it always needs to be an odd number to avoid the split brain scenario. So when you have at least 3 vManage to create a cluster, these vManages can handle then 6,000 WAN edges. If each of your site has just a single vManage, then you can think that one vManage or one vManage cluster can handle up to 6,000 vManages, so 6,000 sites, which is way more than enough. And if your each side has redundancy, even then as well, one vManage cluster would be able to handle 3,000 sites, or a single vManage would be able to handle 1,000 sites if you have redundancy in place that every site has two vManages that needs to be part. And the information, so all the configuration to the SD-WAN fabric can be performed within the vManage in order to maintain the consistency and scalability. So, and each vantage, when you talk about a vantage, let's say this is your vantage, and that vantage is connected to maybe iNet, and then the iNet is connected to vManage. So what's going to happen is your vantage will form up a tunnel, and that tunnel is going to be DTLS, Datagram Transport Layer Security. It is not going to be IPsec. So your vantage will actually form up a tunnel with vManager that is going to be a data plane, that is going to be control plane, or you can say just a tunnel for the management plane. Okay, that tunnel is going to be DTLS tunnel, and it will be maintained throughout in order to see if your vantage is reachable or not. If the data plane tunnel, sorry, if the management plane tunnel is down, if the DTLS tunnel is down due to an outage, and if you're connected to with vManage in some or the other way and want to push up a configuration onto this vantage, then your configuration will not be pushed, but it will be queued. So as the time goes, as soon as the connectivity comes up, then the tunnel, then the configuration will be pushed automatically. You don't need to again go to the device and push the config. Make sense? That's how vManage actually works.
Whenever the tunnels is up, then only the configuration will be pushed to the vEdge, right?
That's correct, yeah. But if the tunnel is down, then it is not going to break the IPsec tunnels. The data plane connectivity will still be maintained.
Yeah, but the communication
It's
is
just
there. But if the
it will
communication is
not.
there,
Yes, please go ahead.
if the communication is there between vManage and vEdge, so there will be no like a communication. The policy will not push, right? Whenever the data like tunnel will up between these two devices, then only the policy will be pushed to the vEdge.
That's correct. Yeah.
Okay. Thank you.
And
How that
this is
tunnel will be formed? How that tunnel will be formed between the vEdge and vManage?
it
Is there
is
any?
formed with the help of VPN configurations that you do. You just need to make sure that the underlay is up. I'm going to talk about that in the vBond section, that how the onboarding actually is done.
Oh, okay, sure, no problem. Yeah, please.
Yeah. And then the next thing that comes up is control plane.
Hey, Abhijit, Vamsi this side. So, how do you
Yes,
deploy the vManage? Is it on the on-prem or a Cisco Cloud or AWS for the vManage?
it can be on-prem or as well as cloud. No limitations. The entire SD-WAN fabric can be on or cloud.
Okay, and you said this, and you referred to server. So the server, is it an ESXi or
ESXi, yes. To ESXi only.
But that will be on-prem, right? Not on the cloud.
Yeah,
yeah?
on-prem, even on cloud as well. On cloud, you're not going to rent, right? You're going to rent a server resource, then install ESXi inside of that, and then install vManage and make it reachable by binding IPs or doing NATing and all. So next, talking about control plane. So we saw how management plane and how data plane works. Then in the control plane, The component that actually provides the control plane functionality is purely vSmart. Again, this is also virtual, but it doesn't require that great of a resource. So your vSmart can function with a default config of 2 GB of RAM and 1 CPU, or I think 2 CPU, sorry, 2 GB RAM and 2 CPU. And it doesn't require any storage. It can function without storage as well. So with one vSmart can actually handle up to 5,400 WAN edges, but with one transport. Which means if you have a WAN edge that is connected to iNet, that is connected to vSmart, then similarly you can have like WAN edges, WAN edges, WAN edges, and like this you can have around 5,400 WAN edges all connected to these and then formed up a connectivity. But if that turns out to be the other way, that the WAN edge is now connected to one more transport, MPLS, then there will be two tunnels, and these tunnels are also DTLS tunnels. You have a choice actually. It can be DTLS or TLS. The choice is only there between vSmart and vManage. You don't have any choice between vManage and vManage or vBond or vManage. For vBond and vManage with the vManage, the only choice is via DTLS. But if you choose to create a TLS session with the vManage, you can do it with between vSmart and vManage. And the difference between TLS and DTLS is nothing major. The purpose is same. It's just that one works with TCP and the other one works with UDP. So DTLS works with UDP and TLS works with TCP. Now, as I said, if your connectivity between the vManage and vSmart is formed over two transports, then there will be two tunnels. One is this and the other one is this. So similarly, if the transports are increasing, then with two transports, your vManage is only going to be able to create or handle 5,400 divided by 2, that is around 2,700 vManages. And if you add another transport, maybe LT, and connect the same, then you will have to divide it by 3 and it will only be able to handle 1,800 vManages. So it depends on to the number of connections and not on number of manage. Unlike vManage can handle around I think 2,000 manages irrespective of number of transport. Why is that? Because if you have vManage over here, vManage will only form a connection over a single transport. So if you have around 3 transport, in one time vManage will only form up the connectivity with over the single transport. So it can either form up a tunnel like this, or it can form up a tunnel like this, or it can form up a tunnel like some other transport. But at one time it will only work with single transport and maintain only a single DTLS connection. If one fails down, then it will go to the other end. But with vSmart and vManage, it is different. Whatever number of transports that you have, those are the number of DTLS connections that it's gonna maintain throughout. Questions?
So in a
Now,
vSmart, if we are having multiple ISPs, that will be managed all the VPN tunnels, right? If one goes down, that will automatically move traffic to the another one, right?
that's correct, yeah.
Okay.
Now, the important thing that comes up over here is all the decisions are actually taken by your vSmart, as I said. And whenever you have vSmart works as a route reflector. So whenever a manage has any update, that update is going to be given to vSmart. vSmart will take decision on that and forward the update to the other manage. This is how exactly it's gonna work. But vSmart does all of these things with the help of OMP, which stands for Overlay Management protocol, because all the overlay is actually being managed by this protocol, overlay management protocol, OMP. It is by default enabled onto all the managers and all the controllers. OMP cannot exist into the legacy network or legacy devices. So SD-WAN is the only product that it works with OMP. But it is a very, very powerful protocol, because it doesn't only handle the route update exchange, it handles the policy distribution, it handles the route information distribution, it handles the IPsec key distribution, it handles lots of other things that you need to take care of. So OMP handles routing, key management, configuration updates, and lots of other things. Every communication that is done between the vSmart and vManage will be done with the help of OMP, overlay management protocol. Without OMP, SD-WAN is not a solution at all. OMP is kind of heart of the solution. So the control plane is highly responsible for encryption of the fabric as well, and the key exchange is also done in a way that whenever vManage creates any keys, those keys are given to vSmart. Then vSmart will do advertise those particular keys to the other vManages. Otherwise, your tunnel will not come up. Now, let's say you have vManage 1 and vManage number 2, and you have a tunnel between both of these, like over here and over here. You have these tunnels up. Now, let's say the connectivity goes down via both of the transports. Then what? So if there is a situation where the control connectivity was established, so control connectivity is nothing but the tunnel between vSmart and vManage. And if there is a scenario where the control connectivity was established, but due to an outage, it has been lost, then the data plane connectivity, which is your IPsec, the data plane connectivity will continue to flow. And by default, the vManages will continue to forward the data plane traffic in absence of the control plane for 12 hours of time. For 12 hours. And this is called as OMP graceful restart timer. And you can change this time from 1 second to 7 days. You can definitely change this particular setting from 1 second to 7 days. You just need to take care of your IPsec key negotiations, because by default, IPsec key negotiations happens, I think, every 24 hours. There are key exchange that happens. If the key exchange is not happened by default, then the tunnel will kind of go down. So when you increase the timer of your IPsec tunnel, you need to take care of something, as Cisco recommends, that configure your IPsec rekey timer double the time of OMP graceful restart. Which means if you have the ability to change the timer to 7 days, right? If you, let's say, make it as 48 hours, then it is recommended to reconfigure your IPsec rekey timer to 96 hours. You get that? So if there is no connectivity again that comes up into picture, then IPsec key negotiations will not happen at all. If you keep your IPsec rekey as default, which is 24 hours, and then just increase the OMP graceful restart timer to 48 hours, then there would be IPsec keys that needs to be resynchronized or negotiated. But because your control plane is down, then the connectivity will fail and it will break the IPsec tunnels that you maintain between the devices. Make sense? Questions?
So you mean to say that suppose our vSmart went down, that time as well the branch will work without any issue, right?
That's correct, yeah. Branches
And
will
suppose,
continue to
okay,
be able to
suppose I'm having site A and site B, okay, site A, B, and C, okay, and there is a connectivity between those sites. And suppose my vSmart went down and suddenly my site A went down. So how the traffic flow will happen? Whether the
If your
traffic,
site is down, then you need to troubleshoot the data plane, right? The controller cannot really do anything in that particular purpose.
but it
If
is
your site
controlling the
is
routes,
up,
right?
sorry,
It is controlling the routes, I think, right?
it's controlling the route for sure. But how it works on the back end, your vManage maintains a cache of the last received routing table. So it continues to trust on that particular routing table and keeps forwarding the data according to the last received information. But if your controller is down and your vanish is down, then for sure your data plane is also going down. The case is when the data plane is good, when your vanish is good, when your site is up, then the connectivity goes down. That's when IPsec tunnels will still be able to communicate with the remote site and send the traffic inside that. So that's how control plane actually works between them. So you can come to a conclusion. Yes.
Would be correct to say instead of saying that when vSmart is able to handle 5400 WAN edges, to say it is able to handle 5400 DTOS tunnels?
That's correct.
Correct?
Yes.
Okay.
Yep. But that depends on the number of transport. If each vanish connects to some other transport, then the number kind of decreases in half.
Okay.
Yep.
Yeah, here except OMP, do we use any other routing protocols, other protocols
No,
except OMP?
I mean on the LAN side, you definitely use this every IGP or EGP protocol that you want. Your IPsec tunnels are established over the IGP only, right? The underlay protocol is going to be IGP or EGP. That can be BGP or something to connect your sites. But in the overlay, in the tunnel, the protocol is going to be OMP. OMP doesn't have anything to do with underlay. And
Do you
underlay
have
doesn't
any
have
specific port number for this OMP?
there is no port number. It is not a session like that, but the DTLS connections are established on port number 12346.
Okay. Good.
Yeah. So when we look at
Hello. Yeah. So what happens if suppose the vSmart is not coming up after the graceful time, let's say 12 hours?
the tunnel will be blocked.
Sorry?
The tunnel will no longer be maintained.
But still the data plane, I mean the data tunnels will be active, right? Between the
No,
spokes.
there is going to be IPsec key negotiations that will be involved when the time comes.
Okay.
Because of the negotiations won't happen, will be terminated. It will get dispersed. But I think you're never going to end up in a scenario where nobody's doing nothing to fix that data plane connection for 12 hours.
Yeah. I think.
Yep. And lastly, we have something called orchestration plane, which is kind of important one. So please pay your attention here. When we look at orchestration plane is basically something that is called as vBond. Now your controllers are going to maintain, like you're gonna have a vManage, then you're gonna have a vSmart, and you have a vBond. These are your set of controllers that you have. Now, if you look at that, all of these controllers are connected to internet, and then there is a site as well. That's a site number 100, which has a vManage that is connected to internet. Now, the final and the probably most important component in the SD-WAN is vBond, because the component is so important that it provides the initial authentication for participation of the fabric, and it acts as the authenticator of that fabric. Okay, so vManage is going to create a DTLS connection with the vBond for the first time. But how does it get the information? So your vManage actually can join the overlay by using two of the methods. Okay, it can join the network by using something called a plug and play, or it can join the network by doing manual bootstrapping. So we will discuss both of them. What is plug and play? Plug and play is nothing but a service, or you can say server plug and play, which is actually hosted in Cisco's data center, and it is publicly accessible. So you log in into the plug and play by going on to software.cisco.com. You log in onto this, log in using smart account. Then create organization profile. Okay, in which you specify number of WAN edges along with their serial number and model and every other thing. Then you also specify who is the vBond of your device, sorry, of your fabric. If say I'm going to have my organization, I also need to create an organization profile, and let's say I gave a name as ABC to my organization profile. Inside that organization profile, I created list of vManage, but so we have to upload a list of vManage that is actually going to be part of the fabric. Okay, in now or in future or so on. If you have the serial numbers and make and model of the device, that I have 20 vManages, all of them are CHs that are going to be part of the fabric, and this is the list of the devices. So it will contain information of the serial number of the vManage that you have. Similarly, there are hundreds and thousands of organization profiles that your PNP server maintains because it's publicly accessible, right? Binded with smart accounts. So after you create your organization profile, it gives a file that is actually called as provisioning file. Okay. And this provisioning file needs to be uploaded to vManager. So vManager then gets to know that, okay, these are the managers that are legit. These are the managers that actually needs to be part of the fabric. And the same information is given to vBond and to vSmart by your vManage. So all of these controllers now are aware about the vManages that are going to be part of the fabric. Are we good over here? Any questions? Till the
So there
controllers
could be
getting
connect.
that.
So there could be connectivity between then vManage, vBond, and vSmart, right? So they
There are
need to
going
be
to
in
be
sync.
DTLS tunnels. There are going to be DTLS tunnels between all of them.
Okay. So suppose we are having a profile or other stuff. Okay. So and today I want to add one device. Okay. And after some days I want to add another device. So I need to follow the
You
same
can do
process,
that.
right? So I
Yeah,
yeah.
same. You can actually log in into your vManage
And
with your smart account.
how that smart account will get uh, mm, connect with the vManage? So is there
You
any
can
way
log
or
in
any
with your smart account. You can log in or sync your smart account directly to vManage.
how we can do that? Is there any way or we have to
We,
place any IP address
vManage is
into
a
our
GUI, right?
Mhm, mhm.
So you can log in into the vManage GUI. There is an option under the administration setting that give your smart account credentials.
Okay. Okay, we can do in a vManage. Okay, got it.
Yeah, yeah.
I thought we can do in
But
our laptop and we can download a provision file and we can upload that.
that's
I was
exactly what you're gonna do. Your vManage GUI is going to be accessible in your laptop only.
okay,
Yeah.
gotcha.
So you get a provisional file downloaded in your laptop. You log in into the vManage GUI, upload that provisional file, and do it. Otherwise, you can log in into the vManage directly, and while logging in into the GUI of vManage, you can give your smart account credentials. So you don't need to download a provisioning file and upload it
Yeah,
manually. It will automatically sync with the PNP server.
okay.
So once these controllers are aware about the number of WAN edges that can actually be part of the fabric, then what's going to happen is your WAN edge gets delivered to the site. New WAN edge, for example, or a legacy WAN edge that has been upgraded to the SD-WAN image. So as soon as you connect it with the internet, the by default DNS address, the factory default DNS address on any WAN edge, be it iOS XE or vEdge or cEdge, it is configured to be the PNP's address, the DNS address of the WAN edge. So for the first time, WAN edge will try to reach out to PNP. Then as it reaches out to PNP, PNP will identify the serial number of that device, and it will be able to identify that which organization is this WAN edge part of. So then let's say the PNP is able to map it that, okay, this particular WAN edge is part of organization number ABC. Once it's able to identify that, then plug and play will reply that WAN edge with the vBond IP address or vBond DNS if the IP addresses are mapped with DNS. So vManage gets the information of the vBond for that organization. Then vManage attempts to create a DTLS connection with that particular vBond. And if the vBond knows, or if the vBond thinks that this vManage is legit, because vManage has given a list of legit vManages to vBond. If the vBond accepts that connection, then in reply, vBond will give the information of vManage and vSmart IP address. And then vManage will try to attempt a DTLS connection with the vManage, and it will try to attempt to DTLS connection with vSmart. And once all of these three DTLS connections are created, then your vManage is onboarded, and all the policy creation or configuration that needs to be pushed, all of these you can push it via templates or things like that from vManage. That's how onboarding of your vManage is done. Questions?
Okay, suppose I have the onboarding is completed. So whether the tunnel between the vBond and vEdge will get vanished or it will still there.
Well, in the documentation, it is said that vBond and vEdge maintains a temporary tunnel, but I see the tunnel is maintained throughout. It is just that the timer gets resetted every 30 minutes.
But do we require that between suppose my device is onboarded, so I don't require that. So
That's correct. That's correct. You don't require that, but the tunnel is maintained throughout. That's what I have observed.
okay. So then how vBond will send information to vManage that this device is under our organization, how that vManage will create tunnel to
vManage
that
also has
device.
a list of all of those controllers by themselves have a list of valid vManage, right?
Okay.
See, I told you that the provisioning file is uploaded to vManage, correct?
Mm-hmm.
So can I say that vManage knows which are the devices that needs to be onboarded?
Mm-hmm.
Does vBond also knows that? Because vManage also gave the information to vBond.
Mm-hmm.
And vSmart also knows that information because vManage also gave the information to vSmart. So they all individually know that which are the legit vManages. But first, the information of vManage and vSmart is given to the vManage only by vBond. Initially, vManage only gets the information of vBond via PNP, right?
Okay.
Then vManage will try to create connection only with vSmart because that's all it knows about. When vBond thinks that this is a legit device, vBond will give the information of vManage and vSmart to the vManage.
Okay.
And then vManage will create a tunnel with vManage and vSmart based on the information that it has.
Okay. Okay, got it.
And that completes the onboarding.
Okay, so this vManage do maintain tunnels with vManage, vBond, and vSmart. So are these three different DTLS tunnels or the only
Yes.
one?
No, these are all different DTLS tunnels.
Okay, got it.
Yep. Now that's a plug and play way of how the communication actually can be done. You can also, now this is all automated process. You won't be able to see anything that what's exactly happening in the inside. Okay, so there is another way of manually bootstrapping the fabric as well, in which you can actually do the basic configuration onto vManage and tell your vBond IP address manually to the vManage that who is my that's who is my vBond. And after that, you can also manually add the number of vManages that actually needs to be part of the fabric into the CLI. I can go to vManage, I can say request vManage, add chassis number this, serial number is this. I can do the same thing in vBond and vSmart. So instead of uploading a provisioning file, I have an option to manually, you can say supplying the information of valid vManages to all my controllers. And when I manually configure the vBond IP address onto the vManage, my vManage will try to create a connection with vBond, and then same process will happen. But in that case, we don't require plug and play at all. It is all manual between the controllers and the balances. That's the other way that you can do it. And that's the way that we're going to do it in our labs as well. Because not everyone has PNP, and PNP cannot be tested in a virtual environment. But I'm going to show you with my smart account that how PNP works and what do you need to do in the PNP by logging in into the smart account. But for performing labs on our fabric, we are going to do it in the manual way. And I would be able to show you step by step that after doing this config, this is happening. You can see that after doing that, that's happening, which I won't be able to show you in PNP because everything is done in a smack of a second.
Do we need to inform anything to the Cisco regarding that we are going to onboard this device?
PNP is nothing but Cisco. You're logging in into the Cisco's website and you're telling Cisco that, hey, these are the devices that I need to onboard. Then Cisco
Do we
gives you
require
the
here any engineer support from their end?
yeah, they are actually, whenever you purchase a solution, it's their engineers who actually onboard your fabric.
Okay.
Yep. Any more questions?
Yeah, I hear manually bootstrapping method. So in between vEdge and vBond, is there any like anything need to be verified between two devices, or is like when it's
Yes.
connected?
So those are device certificates that are signed by your root certificate authority. Basically, all of these controllers do install certificates. Okay. The authorization is done on the basis of PKI certificates or crypto certificates. So you need to install signed certificate, and that signed certificate is presented as an identity to the other controller, to the vBond. vBond will check if the certificate is signed by the same root CA that it trusts on. If yes, then it will onboard that particular fabric. Otherwise, if the certificate is signed by some other root certificate, okay, and even though the device's serial number is added onto the chassis, but still the certificate will not be validated, right? So that will not create a session, or the DTLS connection will be rejected in that case.
So here, when it comes to the vBond, it will check the serial number and side gases number and serial number of the vEdge, right?
Yeah, and the certificate validity as well.
Yeah. When we come to the vEdge, what kind of things it will check here in vEdge? Same thing.
Yep.
It will check the serial number and the chassis number of vBond, or like
No. The certificate number of
only
certificate of that particular.
So how certificate will get downloaded on vEdge? From plug
We
and
will
play
be doing,
server?
yeah, PNP server also has an option to do all the certification and all. But in our case, we are going to set up an enterprise CA. Enterprise root certificate will be configured in our topology. So that server is going to give us a root CA. We're going to install all that root certificates onto all the controllers, including vManages and vBond and vSmart and vManage. Then we will get the certificate signed by the CA, and then we will try to attempt the tunnel.
But in a production, it is not possible, right? So suppose my site is in US and I am doing from here. So I need to take help from plug and play, right?
It is possible very much. You can
Because
have the certificate.
We need someone there in the
You can
office,
just
right?
take the remote and do that particular thing pretty well. But mostly in the enterprises, it's going to be Cisco who is going to act as your CA. Yep.
Okay.
It's just for the our testing purposes that we're gonna do it into the local scenario possible. Because we cannot ask Cisco to create a root certificate for our lab environment.
So vBond will check the certificate and the serial number, chassis number, right? Once they matches, then it will allow them to create a tunnel with manage and vSmart, right?
That's correct, yeah.
Okay.
So without communication with the vBond, can I
It's not
manually create
possible for your
tunnel with?
WAN. No, it's not possible.
Okay.
That's why I said vBond is the most important thing into your
Okay,
fabric
so
because it's
authentication part will be done by vBond, and then after we'll route to vManage and vSmart.
yep. Then after vBond doesn't have anything to do in the fabric. It's all vSmart and vManage.
Okay, got it.
But again, if all of those tunnels are broken, then I think no. Even after that, once you get the information of vManage and vSmart, then you don't really require anything, or you don't require vBond for anything. vBond is just there to give you the information of vManage and vSmart. Once you become part of the fabric, then you already have the vManage and vSmart information onto your Vantage, right? So even after all the tunnels are broken, you still can create the tunnels directly with vManage and vSmart without the need of vBond. Are we good? That's why we say vBond is kind of the orchestration plane.
Okay, so how does this PNP and vEdge will be communicated?
Via internet.
Okay.
Yep. PNP is publicly exposed on internet. You need to give the connectivity to internet on your Vantage. And because the DNS address by default is configured on PNP, the first server that it's going to communicate with is going to be PNP.
Okay.
But in the manual way,
Okay.
we change the address to our vBond address. So first it tries to communicate with vBond only in our lab scenario.
Okay. So you mean to
Yes,
say that when we change our iOS from iOS XE to SD-WAN, that will redirect to PNP by default, right?
Yeah.
Okay.
Cool. I think we're good then. So that was the motive of today's agenda, where we had to get familiar with the orchestration, the management, the control, and the data plane, and see how it works.